All right, here are solutions for the first quiz for Math 112. So what's going on here is you're given the graph of a function, it's called f of x, and you're asked to sketch an approximate graph of f inverse of x. And there's at least two different ways you can do this. I think the easiest way is to kind of look for some points. So I even try to hint at that in this little parenthetical comment where I say label at least 3 points on the graph of f inverse. If you notice, for example, that the point negative 2, 0 is on the graph of f, well, what that means is the point 0, negative 2 must be on the graph of f inverse. One way you can think about an inverse function relative to a function is we're switching inputs and outputs. And since the input is the x coordinate and the output is the y coordinate, all I gotta do is switch the x and y coordinates of a bunch of different points. So here's another one. Negative 1, comma 1 is on the graph of f. Therefore, on the graph of f inverse would be 1, negative 1. Similarly, 1, 2 is on the graph of f. So therefore, 2, 1 must be on the graph of f inverse. There are any other easy ones here? This looks like integer coordinates. 5, comma 3 is on the graph of f, therefore 3, comma 5 would be on the graph of f inverse. And that's probably sufficient. I bet we could sketch a graph that goes through these different dots that has roughly the right shape and call that good and get full credit for this problem. It's worth pointing out that another way that you can do this is recognize that switching the x and y coordinates is equivalent geometrically to reflecting over the line y equals x. So the line y equals x is this diagonal line that goes through the origin. So while you don't have to draw it, it might help to have that as kind of a guideline. If you take this red curve and flip it over this green dotted line, the graph that you end up with would be the graph of f inverse. I'm no artist, and it's even worse when I'm trying to draw on a tablet like I am now, but hopefully that's good enough. We can call this f inverse of x. I'll label the points with integer coordinates a little bit larger, although you don't have to choose those specific ones when you're sketching your own graph. And then the next three problems come from more of an algebraic point of view. We're given this function g of x and asked to figure out g inverse of x. So I think the way I taught this in the videos is I said that was a 4-step process. Step 1 is we change g of x into a y, so y equals 2x minus 6. And then we recognize that this was an equation that represents the function, but what we want is an equation that represents the inverse function. And the way you switch from the function to the inverse function is you switch the inputs and the outputs. So informally speaking, you switch the x's and the y's. And then while this equation represents the inverse function, it's not the inverse function written in function notation. To do that, I have to solve for y. So get this y all by itself by maybe adding 6 to both sides of the equation and then dividing both sides of the equation by 2. I get y equals x plus 6 over 2. Or if you prefer, we could call this 1/2 x plus 3. Either way is totally fine. I think either of these would be acceptable final answers, although technically since it asks for g inverse of x, maybe I should write it in functional notation and say g inverse of x is x plus 6 over 2 or half of x plus 3. And then what I was going for here is you can always check your answers. When you compose together a function and its inverse function in either order, you should always get x as the answer. So I was originally going to ask you to compose together the function and the inverse function both ways, but that seems like more work than maybe you need to do. So why don't I get rid of one of these, maybe this one just arbitrarily, and I'm going to change the problem so you only have to do it one time, just so we don't jam in too much work in one problem. To figure out g of g inverse of x, I like to first rewrite it in this form. It means the exact same thing, I just think this is easier to evaluate. And then what you can do is work from the inside out, replace g inverse of x with what we just said it was equal to, and either of these two forms are fine. My guess is more students will leave it this way, so maybe I'll use that in my solutions, although again, either way would be totally fine. And then to evaluate g of x plus 6 over 2, well, all you have to do is look at g of x up here and copy exactly what you see here, except replace all of the x's with whatever in these parentheses. So in these parentheses are x plus 6 over 2. So I'd write 2 times, and then instead of writing this x right here, x plus 6 over 2, and then minus 6. And then I'll simplify this a little bit. Let's see, this 2 and this 2 can cancel out. You can think about this as 2 over 1. So I get x plus 6 minus 6, and plus 6 and minus 6 just leaves me with an x, which is what I was expecting to get when I composed together a function and its inverse. Question 3, we get another function, h of x, and we're again asked to figure out h inverse of x. This function's a little bit more complex than this function, so the algebra will be a little bit more intense, but I don't think it'll be too bad, and it'll still be that same 4-step process. So step 1 will be to change h of x into y, so I get y equals x minus 4 to the 3rd power minus 1. And then recognize that this is an equation that represents the function, but what I want is an equation that represents the inverse function, and the way I get there is I switch the inputs and the outputs. And then you're like, all right, great, I got something that represents the inverse function, but it's not in functional notation because it's not solved for y. So solve this guy for y, maybe first add 1 to both sides of the equation to to get x plus 1 equals y minus 4 to the third power. And then if my goal is to get this y all by itself, I got to get rid of this 3 up in the exponent. So I can take the cubed root of both sides of the equation. So the cubed root of x plus 1 would be equal to y minus 4. And now I'm almost done. This y is all by itself if I just add 4 to both sides, and I end up with y equals the cubed root of x plus 1 plus 4. And while I think this would be a totally acceptable answer, I'm going to go ahead and do what I said that I would do in the videos and rewrite the y as h inverse of x, because technically that's what it asks for. So h inverse of x is this cubed root of x plus 1 plus 4. And much like number 2, you're not done after you figure that out. I ask you to kind of do something with that. What I ask you to solve h inverse of x equals 6. So there's at least 2 options of how you can do this. I think what most people will think to do, which is why I added this however you want, to kind of try to give you a hint that there's multiple ways you can do this, and maybe there's an easier way than the obvious way. But I think what most people would think is be like, all right, I just figured out h inverse of x, it's this thing, and I want to figure out when that equals 6. Fine, the cubed root of x plus 1 plus 4, which is h inverse of x, let's set that equal to 6 and let's solve. Well, to solve this equation, you subtract 4 from both sides of the equation, and that gives me the cubed root of x plus 1 equals 2. And I want to get this x alone, so I got to get rid of this cubed root. To do that, I'm going to cube both sides and get x plus 1 equals 2 cubed, in other words, 8. And then if I subtract 1 from both sides, I get x equals 7 as my solution. And this all works out totally fine, and I guess that wasn't that bad to solve, so maybe there was nothing wrong with doing it this way. But just FYI, another way you can do this is asking you when the output of the inverse function equals 6. And since all the inverse function does is it switches inputs and outputs of the function, the output of the inverse function equals 6 is equivalent to figuring out when the input for the function equals 6. So another way to figure it out is just to figure out h of 6. Just put 6 into the function as opposed to figuring out when 6 comes out of the inverse function. And putting 6 in, generally speaking, is easier than figuring out when 6 comes out. All I gotta do is change all the x's into 6. So I get 6 minus 4 to the third power minus 1. And 6 minus 4 is 2. So I get 2 cubed minus 1, and 2 cubed is 8. So 8 minus 1, and I end up with this same 7. I think this was slightly easier if you happen to see to do it that way, but really it's fine either way. Last problem on the quiz deals with a rational function. So the key thing here is this kind of variable down in the denominator is going to make solving this a little bit more challenging. All we're asked to do here is determine the inverse function. So there's no kind of step 2 once you figure that out, like there were in 2 and 3 above. And the way we'll figure it out is the same way you've been doing it. First, change j of x into a y. So I get 2 over 4x plus 6 equals y. And then switch my inputs and my outputs. So I get x equals 2 over 4y plus 6. And then solve for y. And you're like, this is easy, same thing. Well, the challenge is solving for y here is not easy. I mean, we did a couple of examples of this type, so hopefully you have a strategy in mind. But I think it's a lot harder to solve this for y than it was to solve, I don't know, this up here or this up here, for example. The way I think about it is, well, it's hard because the y is down at the bottom here. So let's get the y out of the denominator by multiplying both sides of the equation by 4y plus 6. So then on the left, I'd have x times that 4y plus 6. And on the right, I would just have 2. Because if I multiply this by 4y plus 6, that new 4y plus 6 and this old 4y plus 6 cancel each other out. And that gets me this far. Now we just want to solve for y. There's 2 different ways you can do this that'll get you the exact same answer. Either you can distribute this x through the parentheses if you want, or you can just divide by x right now and call it 4y plus 6 equals 2 over x. I don't know which way is easier. My guess is that maybe more students would do it this way, so I'll do it this way. But just to be clear, if you distributed the x through the parentheses at this step, that's totally correct as well. Either way, our goal is to isolate this y, so maybe we get rid of this 6 next. So we can call it 4y equals 2 over x minus 6. And then to get this y all by itself, well, you could divide both sides by 4, but then you'd end up with fractions inside fractions, which is not the prettiest thing to look at. So maybe instead of dividing both sides by 4, I'll multiply by 1/4. So I get 1/4 times 2 over x minus 6. And this is a perfectly acceptable answer. You could say j inverse of x equals exactly what you see here, 1/4 of 2 over x minus 6. However, there are other ways that you can write this, so I'm just going to write or here, not to imply that this is any better. You get rid of the parentheses by distributing the 1/4 through. So I would have 2 over 4x, and then that 2 and this 4 could cancel, and I would be left with 1 over 2x. And then the 1/4 times the 6 would give me 6 over 4, which I could reduce to 3 over 2. If you really wanted a single fraction instead of the difference in two fractions, you could multiply the top and the bottom by x here, and that would give you the common denominator of 2x down in the bottom. And up top, we just have a 1 from this guy, and this would become 3x if I multiplied an x on the top and the bottom. So I'd get 1 minus 3x. There's lots of other ways you can write it, but here's a few different ways. I don't need you to be able to write it all of these different ways, but having the ability to switch between these forms, or at least see that they're equivalent, is beneficial later on. So I figured I'd demonstrate it for these solutions. That's all I got.